Once we found out the reaction, then we must go for drawing free body diagram of this figure. Now there are three bars in series, so let's start with the free body diagram. In free body diagram, we need to calculate the forces on each and every bar. To calculate the forces on each and every bar, we will use a section method. Now, in this section method, we need to draw a section somewhere in between on each and every bar. For the first bar, I have drawn this XX section somewhere in between. Now, to find out the force on this first bar, I will sum all the forces either on the right hand side of the section or on the left hand side of the section. On the left hand side, there is only one force, so that will be 150 kilonewton. Equal and opposite force will be 150 kilonewton. You can solve this problem from right hand side as well. So on the right hand side there are three forces. One is 300 kilonewton, second one is 200 kilonewton and 50 kilonewton. If you try to find out the resultant, again you will get the same result, that is rightward 150 kilonewton. So go by any side, your answer will be right. Now again take another section for the second bar, and I will name this section as x dash and x dash. Now try to sum all the forces either on the left hand side or on the right hand side. On the left hand side there is 150 kilonewton and 300 kilonewton. So 150 kilonewton is going leftward and 300 kilonewton is going rightward. The resultant will be 150 kilonewton rightward. Equal and opposite will be there on the another end. If you try to approach this problem from right hand side as well, you will again get, see, from the right hand side there will be two forces. One is 200 kilonewton going leftward and 50 kilonewton rightward. So the resultant of it will be again 150 kilonewton leftward, and it will show the effect of compressive nature on the second block. Similarly, we will try to calculate the forces on the third bar. Now, as soon as we have drawn this free body diagram with the help of section method, we will get to know the force on the first bar is 150 kilonewton. Force on second bar will be 150 kilonewton compressive, that's why this minus sign is there. Force on third bar will be equal to positive 50 kilonewton. Now, as discussed in the previous lecture, the total deformation will be equal to deformation in first bar plus deformation in second bar plus deformation in third bar. So let's try to write it down. The total deformation will be equal to deformation in first, deformation in second, deformation in third. Deformation can be given by the formula PL by E of first, PL by E of second, PL by AE of third. Now we have already calculated what will be P1, what will be P2 and what will be P3. Now let's try to find out the other data from the given data. So A1, A2, A3 is already given to us. A1 equal to 1200 mm square, A2 is 2500 mm square and A3 is 1000 mm square. A1 1200 mm square, A2 2500 mm square, A3 equal to 1000 mm square. Now E is already given to us, that is E1 equal to E2 equal to E3 equal to 200 GPa, which is nothing but 200 into 10 to the power 3 MPa, which is nothing but 200 into 10 to the power 3 Newton per mm square. Now The remaining is length. Length of first, second and third bar is already given to us. 4 meter, 3 meter and 3 meter. So if we try to see this formula of delta L total, we will get to know all the terms from right hand side is given to us. We just need to find out the total deformation. Now here for the first case your P will be 150 kilonewton. So 150 into 10 to the power 3. I will suggest to solve this problem in the standard dimensions or standard dimensions only. It means we will take load in Newton, length in mm and area in mm square. And E in Newton per mm square only. What will happen with this? Whatever deformation we will get, that will to be in mm only. Okay. So all the dimensions which we will take it should be in Newton, it should be in mm or it should be in mm square. Now let's try to put these values. 150 it is in terms of kilonewton, so we will convert it into Newton. Next, length is given in terms of meter, we will again convert it into millimeter, so 4 into 10 to the power 3 millimeter. Next, A is given as 1200 mm square, it will remain as it is. E is given as 200 into 10 cube, so it will be Newton per mm square. Next value, see, second load or the load on the second bar is of compressive nature, so we will use minus sign for it, and the value of the force is again the same, that is 150 kilonewton. Length is 3 meter, area is 2500, E is again the same, that is 200 into 10 cube, plus for the third bar the force is of tensile nature, so there will be a plus sign. Length is 3 meter, area is 1000 mm square, E is 200 into 10 cube. Now if we try to solve this calculation, you will get to know total deformation will be equal to 2.35 mm. Thank you.